Hello everyone! In today's lesson we'll be studying the basic rule of integration, which is an important subject in the IB Mathematics topic 5, which is calculus, and this topic is under the IB Mathematics AA and AI, standard level and high level. Here we'll explain the power rule of integration, and we will explain what we mean by this plus constant c, and what happens when n equals -1. So here, to apply the power rule of integration, or to integrate x power of n, first we increase this power of n by 1, or we add 1 to the power, and then we divide by the same new power. Then we add the constant c that we'll explain now. So here we have an example. We will integrate 6 multiplied by x power of 2. First, to integrate this, we keep the number 6 that's multiplied by x as it is. Then we will integrate now x squared as we learned here. So it will be now, we will increase this power of 2 by 1 as we said here. So it will be 2 plus 1, 3. And then we will divide by the same new power 3. Now we will simplify our answer. Here we have 6 divided by 3, which is 2. So it will be 2 multiplied by x cubed. So now, what is the story of this number or constant plus c? Keep in mind that integration is the opposite of differentiation. So that's why sometimes we call it the antiderivative. We call the integration the antiderivative, which means that if you differentiate your answer that you got from this integration, you will get back the original function you started with. Here, if you differentiate this, you will multiply 3 by 2, which is 6, and then you will decrease power of 3 by 1, it will be x squared. So now, is this the only correct answer for this integral? No, we have infinitely many correct solutions. If you put here plus or minus any random constant number, like let's say 7, and differentiate this, it will be still 6x squared, because when we differentiate 7 we get 0, so the final derivative for this will be 6x squared only. It would be the same if you put any plus or minus constant number here. So that's why we generally put plus constant c. And when we differentiate this for any value of c, we get 6x squared. The derivative of constant is 0. So here we would have also plus c. Here we have another example that's very simple. Integration of x power of 3. So to integrate this, we increase this power of 3 by 1. As we said, it will be 4. And divide by the same new power 4, we put then plus constant c again. Here we have 8 divided by x power of 5. Here we cannot integrate x power of 5 if it's in the denominator like this, so that's why first we write it in the power form like this. So we will rewrite the function like this, 8 as it is, x. If we put this x power of 5 up in the numerator, then we will reverse the sign of 5 and it becomes -5 then dx. So now we integrate normally here. We will add 1 to this power -5, then we get -4 and divide by the same new power plus c, which will be now 8 divided by -4 would be -2, and then we will put the x power of -4 down back and reverse the sign again. So it will be x power of 4 plus constant c. Here we have integral of square root of x. As we know, any square root can be expressed as power of half. So here we can write it in the power form like this. Now to integrate, we will add 1 to this power of half. Half plus 1 would be 3 over 2. And then we will divide by the same new power, 3 over 2, then we have plus c. Here, we can take this denominator up in the front, but we have to take the reciprocal of this because, as we know, for example, 1 over 3 over 2 can be written like this, 2 over 3. We can take the fraction up and take the reciprocal of it. So here, we will write 2 over 3 in the front, then the x can be written like this. Here, we can change this back into a radical form. The numerator 3 will be here inside, and the denominator 2, we put it here outside. But in square roots, we don't write the 2 here generally. It's automatically here 2 for any square root. Then we have plus c. Here now we have an integral of just a constant number without x, integral of 7. So simply, when you have only a number like this, 7, the integral will be just 7x. We just put here x and then plus c. Because when you differentiate 7x back, you will get 7. So in the same way, for example, when we integrate 10, it becomes 10x. When we integrate, let's say, negative 11, it will be simply negative 11x plus c. So we just put here x and then plus c for any constant function. Here we have the integral of the cube root of x squared. First, we will write it in the power form. X can be changed into a fractional power. The inside 2 divided by the outside 3. So the inside 2 by the outside 3. All of that now multiplied by dx. So here we keep the 20 as it is. When we integrate this x, we add 1 to this power. 2 over 3 plus 1 will be 5 over 3. Then we divide by the same power, 5 over 3 plus c. Now, as we said, we can take the 5 over 3 up in the front, but write it as 3 over 5, as we did in a previous example. We take the reciprocal, and then we will change the x into a fractional or radical back, the inside 5, the outside 3, so here we have 5 and 3, plus c. Here we have 20 multiplied by 3 will be 60, divided by 5 is 12. So we have 12, the cube root of x power of 5. Let's now move on to this integral. Here we have a function that has 3 terms. So like differentiation, also integration is distributable over addition or subtraction, which means we can integrate each one of these terms separately one by one. But here first, we will rewrite this term in the power form. So it will be now, we keep the 8x cubed as it is, minus 6. Here, the power on x inside is 1. Then this x can be changed into x power of 1 over 4, as we said. But when we send it up to the numerator, we will reverse the power of 1 over 4 into negative 1 over 4 plus 2 as it is here. So now when we integrate, we will keep 8 as it is. So we have 8. And now when we integrate x cubed, it will be x power of 4 over 4. Minus now, here when we integrate x power of negative 1 over 4, we will add up 1 to this power. Negative 1 over 4 plus 1 will be positive 3 over 4, and then we divide by the same new power. Here, of course, we keep the negative 6 that's multiplied by x as it is. Then, when we integrate a constant 2, as we said above, it just becomes 2 times x immediately, plus c. Now here we have 8 divided by 4, which is 2, multiplied by x power of 4, minus now we keep the 6. We can take this fraction up and have the reciprocal 4 over 3, then x power of 3 over 4 plus 2x plus c. It will be 2x power of 4 minus 6 times 4 would be 24, divided by 3 would be 8, so we have 8, and the x can be written like this, the inside 3, and the outside would be here 4, plus 2x plus c. So this is the answer. Now here we will have an important note on this formula. As we said, n cannot be -1. So what happens when n is -1? Here, if you replace this n by -1, it will be like this, -1 dx. In this case, we don't integrate it like following this rule here, because this rule is only for n when n is not equal to -1. So here, it will be wrong to say we add up 1 to this power, so -1 plus 1, which will be 0, and then we divide by 0 again. This is error or undefined because we cannot divide anything by 0. Instead, when x is -1, to do it in the correct way, x -1 can be written like this, 1 over x power of +1 times dx. Here, this is a standard integral in the integration rules, 1 over x, that we will study later, but when you integrate 1 over x, it becomes natural log of the denominator x in the absolute value plus c. We will study this rule and many other rules later in more advanced integration rules. I hope that you have found the video helpful. Please hit the like button and consider subscribing, and stay tuned for more videos about integration.